we have a binomial distribution question, and for a lot of binomial distribution questions you'll find that we'll use the calculator. So let's have a look. In a large population we have the probability, so that's going to be P is 0.1. The probability someone's left-handed is 0.1. We are going to say there are 10 people chosen from random, so N is going to be 10, and for part A we're looking at X equaling 3. So let's go to the calculator and we'll see what we do. Now if we need to show some working out, what I would show here is P equals 0.1, N equals 10, X equals 3, and then just write that you're doing it on the calculator. The way to do it on the calculator is we go to statistics, then calc, then distribution, and then we're going to go down distribution, and it's not very easy in this window until we find binomial probability distribution. So for the questions where we're told that exactly a certain number are left-handed or right-handed or they win or whatever, then we're looking at probability distribution. If we have a question where we say at least a certain number, then that'll be the binomial CD, which is cumulative distribution. So we're going to go probability distribution here and say next. Now we're going to put in our numbers here. X is 3, number of trials is 10, the possibility is 0.1. We go next and we find out that the probability is 0.557, whatever. So therefore I was going to say here, probability X equals 3 equals 0.0574. And there's our answer. For part B, this is a question where we need to use the cumulative because we have at least 9. We can do this two ways. We can either say that at least 9 means it's everything, well, 9 and 10, and add them up, or we can do it by the calculator. Let's do it both ways. So the first way, we can say the probability that there are at least 9 equals the probability that there are 9 plus the probability that there are 10. Now, the probability that there are 9 will be 10 C1 of our, so we're going to do that first, that's our number of combinations times the probability of winning, so P to the power of 9 and Q to the power of 10 minus 9, which will be 1. So that is 10 factorial over 9 factorial 1 factorial times 0.1 to the power of 9 times 0.9 to the power of 1, which is 10 times, so 10 factorial over 10, 9, 1 factorial is 10 times 1 times 10 to the negative 9 times 0.9, so it will be 9 times 10 to the negative 9. Ridiculously low number. Okay, then we have to add to that the probability that X equals 10, so that will equal 0.1 to the power of 10. So the total that X is greater than or equal to 9 will be 9 times 10 to the negative 9 plus 1 times 10 to the negative 10, which equals 9.1 times 10 to the negative 9. And that would be my answer. Hugely small answer. Let's do it by cumulative distribution on the calculator. What we would do is we go back here until we pick the right distribution, which is cumulative distribution. Then our lower number is 9 and our upper is 10. So we're doing everything between 9 and 10 outcomes out of 10 trials with a probability of success being 0.1. And we say next, and we get 9.1 times 10 to the minus 9. So that's how we do that. Both the calculator and my brain agree with each other, as rare as that is, so that is clearly happy days. And for the last part of this question, we're asked, what is the probability that more than 1 will be left-handed? So this is the probability that x is greater than 1. Again, we can do this two ways. We could say this is the same as 1 minus the probability that x is 0 and the probability that x equals 1. Or we can do it on the calculator with the cumulative. Seeing we know how to use cumulative distribution, let's do this by hand. So therefore it's 1 minus the probability that x is 0 will be 0.9 to the power of 10. Don't forget our brackets. And the probability that x is 1 will be 10c1 p of 1q to the power of 9, which is 1 minus 0.9 to the 10 minus 10 times 0.1 times 0.9 to the 9, which will equal 1 minus 0.9 to the 10, which should be a plus there, shouldn't it? Plus 0.9 to the 9. And once we get to this stage, we'd be expected to use our calculator anyway. So we'll go to the calculator and we'll say 1 minus bracket, let's do 2 brackets just so I know I'm doing the right thing. 0.9 to the 10 plus 0.9 to the 9. That looks all right. And there I get a number that's really not very useful, so let's turn it into a decimal, and we get 0.2639. And that's using the calculator. Now let's double check our answer by using the calculator for the whole calculation. So let's go to system. No, that's not where we want to go, is it? Let's go to the menu and let's go back to statistics and calc and distribution. We're going to use our binomial distribution. And what we'll do is we'll say this is cumulative. And remember, when we're talking about more than 1, our lower boundary will be 2 people. The upper will be 10. There are 10 trials, and the possibility of 1 being successful is 0.1. We'll hit that, and wouldn't you know it, we get 0.2639. So once again, we're on fire and in a world of happiness.